Okay. So we were doing yeah, here we go. Okay. Gotta find my notes so I get this all correct here. Okay, so again, EX is E0. This is the one that gets the most interesting because we're going to look at a case that's halfway between those two. And EY is going to be E0 cosine of KZ minus omega t plus, and this time it'll be pi over 4. So that's a phase shift of pi over 4 this time. So considering KZ is 0, and then look at omega t is 0, what's EX and EY? What do you have for that? EX is going to...
Is that KT equals 0?
That's KZ.
Z.
Z in here, yeah. This is KZ minus omega t. It's KZ is 0. That's true for all of them. And then this is the case of omega t is 0. So if you look at this, you're going to have the cosine of, and this is just 0.
So 0.
No.
Oh, wait. Sorry, 1.
Yeah. E0.
E naught.
There we go. Okay. And then this becomes cosine of pi over 4.
Which is root 2.
Yes.
So
E naught
times root 2.
It's divided. It's equal to 1 over root 2, actually.
Ah, yeah.
7,
Okay.
7. Yeah. Okay, that was fun. Now let's look at pi over 4. I'm going to do finer divisions here. EX is going to be E naught cosine of minus pi over 4.
So it's the
naught over square root of 2.
Yeah, E naught divided by the square root of 2 EY. E naught cosine of, and this is minus pi over 4 plus pi over 4.
so it's times 0.
This is 0.
Or, so it's 1.
1 again.
So E naught.
E naught, there we go. All right. Omega t is pi over 2. EX is going to be E naught cosine of pi over 2. Lucas, what's this one going to be?
It's going to be 0.
Very good. Cosine of pi over 2 is 0. And EY, can you give us that one as well, Lucas? This will be cosine of minus pi over 4. I'm sorry, minus pi over 2 plus pi over 4.
Mm-hmm. So it's just going to be E naught over root 2 again.
Exactly. Okay. Let's keep going. Omega t, we're going to make it 3 pi over 4. EX is going to be E naught cosine of minus 3 pi over 4. I've got a missing minus sign right here. That should have been cosine of negative pi over 2. It doesn't change the answer. Okay, Ben, what do we have here? You have to turn your mic on.
Sorry, negative E naught over the square root of 2.
Minus E naught over root 2. Yep, that looks right. And what about the y component? Again, Ben.
That would be 0, I think.
Minus 3 pi over 4 plus pi over 4 is minus pi over 2, which is 0. Okay, let's try and graph this now and see what exactly we have. So up here, the first one, we've got E naught.
John, you're going to have to make those lines really dark. It's hard to see right now.
Yeah. Well, let's just make it, yeah, okay. So here's E naught. That's the x component. And then the y component, it's positive, it's smaller. But because there is a y component, the net result is actually larger than E naught. So we're going to have something off at an angle like that. Look at the next one. Now it's the x component that's a little less than E naught. It'd be 0.7 E naught. And the y component is the full E naught. So now it's pointing up a little more. Come down here, the third one for pi over 2, and we don't have any x component. We have only a y component, and it's this smaller value again. And then if you come down here to 3 pi over 4, we have a negative x component, this smaller number, and no y component. Now let me just see if I can draw this. Oh, I better. Yeah. I'm going to make these bigger than they were there. We started with a vector that went off this direction. Then the next one was more up this way. Those two had the same length. Then we had a vector that is shorter. In fact, it would be exactly the same as the y component of the first one. And then we had one that was the same, well, it's that same smaller value again, but it's in the negative y direction. Those are the 4 values we've got so far. And maybe you can see that this is starting to form an ellipse that goes around like this. So that's our elliptically polarized light. It would have a major axis that's along this 45-degree direction. And it would be left circularly polarized. So a mixture of linear and circularly polarized light in that fashion. Does that all kind of make sense? And maybe that helps you get through the problem. In the problem, I would note that you need to be a little bit careful about signs. So we did this whole thing as kz minus omega t. But you can also write these the other way around as omega t minus kz. And it just switches a bunch of your signs. So be a little careful on that. And then whether the phase shift is a plus sign or a minus sign, I think that ultimately would determine whether you had right or left circularly polarized light. So I think that'll help you get through that problem. This is about all I had to do. Do you have questions? Is there anything that you're stumped and need some help with?
some of us met yesterday and kind of worked through the problems. But I think questions on those can wait until we actually go over them,
Okay. Okay.
unless Ben or Lucas wanted to ask something now.
No, I don't think I have anything. I thought we were able to work through them fairly well once we got started.
Yeah.
The first one definitely gave us the most time, number 4.
Yeah.
But yeah, this makes it a little more clear.
Yeah, I hope so. I'm sorry. I wish I would have done this, on Monday. Would have made sense, but wasn't ready for it yet. So I'm still figuring this out. We all are, I guess.
Hmm.
But we'll get there. We'll eventually get there. I did find out some good news. Apparently, in the governor's declaration, I am considered an essential worker. And so that means that I am allowed to visit my office and could go up there, and so I can poke around in the lab and that sort of thing. So I don't know how much. I won't be doing that just all the time. I probably still do some stuff here from home. I haven't exactly figured out that yet. I just learned that this morning. So down the road, I may take a trip into the lab and maybe even do one of these Zoom sessions from there. I have to take along a camera or something and see what we can do. I wish I had a better camera. That's the biggest trouble if we're going to do this kind of. I think Zoom will support a much better video than what I am producing here. So I just need to get some better technology here. I also need to upgrade my my program on a computer so we don't get this stupid 40-minute interruption like that. So, all right. Well, we'll see each other again at 9 o'clock tomorrow morning. I'll try and post the recording of this. Aaron, you can look at the beginning of it if you want.
Yep.
So,
I will set an alarm for myself. So I,
John, can we change the time of the meeting tomorrow to 2, like you said in your email?
Oh, well, I hadn't thought about that. Let's see, tomorrow, well, I was thinking, I'm gonna look at my schedule here. Yeah, tomorrow, the thought was we were gonna go over the problems and then I was gonna open up a quiz. Isn't that the plan? Had I not said that?
a one problem quiz, right?
Yes, it won't be extensive at all. It'll be a one simple problem. And then I need to post some materials for you to start working on the next chapter. Once again, we've already done some of this in class. We just didn't do the problems yet. And so we're going to kind of catch up by doing mainly the problems. So I won't have a whole lot more to present, but there is some more stuff that I didn't get to that I want to try to add. So I guess we could in general meet at, do you want to in general meet at 2 rather than having this one day when we meet at 9? Is that what you're suggesting, Ebtihel? Well, would you all prefer that? It doesn't make a whole lot of difference to me.
Yeah.
Sounds like it doesn't matter to much of anybody. Ebtihel doesn't like to get up at 9, I'm guessing.
It's 8 here. It's not even 9. It's worse.
I don't know. Are any of you in different time zones? I know the times are goofed up.
I am.
You are, okay. And I think, is it Moodle or is it Zoom? One of them, I think it's Moodle, that does not show times correctly. When you look on Moodle, it tells you the time according to me. You have to translate that. It doesn't do the smart thing. I think that's because Moodle just was not designed for this situation where people are coming in remotely. It's more assuming everybody's at one institution somewhere and nobody had to deal with this before. So that's a problem. I've had a couple of students get caught by that. But just be aware of that. All right, well, let's meet at 2. We can do that. We'll do our 2 o'clock meeting tomorrow. And then at the end of the meeting, from 3 until, I don't know, midnight or something, you can do the quiz at your leisure. And then we'll meet again on Friday at 2 for some more lecture on, that'll be on chapter 9.
On Friday, would it be okay if I just watched the video recording? So I have a internship interview still.
Oh my
So-
goodness. Sure. We'll, somebody remind me on Friday, we'll just record the session again.
All right, perfect.
Everything should be fine. Yeah. Okay. Well, so far so good. This isn't quite the same thing. We're missing out on some stuff, but it's a whole lot better than nothing. I'm starting to figure some of this out and managing to do all right. I hope you all are. So, okay, I'll see you tomorrow at 2 o'clock.
Have a good one. Sorry about being late again.
That's okay. We'll see ya.